new. Next week will be exam review, which I know will make you very happy. As I said, I've almost got the final exam in place. I have to check a few things on it. So over the weekend, I will make up some practice problems for everybody to work on, and that'll help you with the final, okay? Hope that's good, and then next week we'll do a lot of review. And then you have the final on the 13th, I forget what time, 11 in the morning or something? 11:30, okay? And I'll post the location this weekend. So for the many of you who are not here, you'll have some information. Hopefully for those of you who are here, you'll be rewarded just a little bit for doing me the courtesy of showing up on a regular basis. All right, so let's practice some more U substitutions, because I can assure you, you'll need to know these for the final. Let's give you guys a few of these. Take them in the book. These come out better if somebody's done them first. How about? Let's just do it, yeah, okay. Okay. Okay, there's 4 to get us started. So for the first one, you're going to want to do that trick where you make u equal x minus 5, and then u plus 5 equal x. Give you guys some clues to help you along. Here you're going to want u equal x minus 5. Here you're going to want u to equal 2x to the 4th minus 1. You're going to want u to equal 12x squared plus 4x plus 3. And here you're going to want u to equal log x. All right. Let's start trying problems. So, first one, we let u equal x minus 5. How do we know what to do with a problem like this? Well, remember, you're always looking to see if the integrand contains a function and its derivative. Problem is, the derivative of x minus 5 is 1. That's not x. And the derivative of x is 1. That's not x minus 5. So when you get that type, you do this little trick. Okay? Because the derivative of u, du, is dx. So you do have the function and its derivative. The problem is what you do with x. So if you let u plus 5 equal x, then you can rewrite this integrand. This becomes u plus 5. This becomes u. And this just becomes du. Didn't really change. So all you really did was use a little trick to turn this from a fraction that you can't break up into a fraction that you can make u over u plus 5 over u. Okay? You don't even really need to do U substitution. There's another trick to this, but I won't confuse you. One trick per type. One technique is usually all you need. Okay. So u over u is 1. All right. The antiderivative of 1 is u. And the antiderivative of 5 over u is 5 times the log of u. Okay? Because the derivative of u is 1, so the integral of 1 is u. And the derivative of log is 1 over u, so the antiderivative, the integral of 5 over u is 5 log u. And then you just substitute back. So it becomes x minus 5 plus 5 log absolute value of x minus 5 plus constant. Okay? It's much easier when I do it. Part of it is I've done many, many, many integrals in my life. Far too many. It's not whether it's thousands, it's in the tens of thousands. You know, it's hard to be fooled on these anymore. So as I said, so the clue is that this is the same power. These x's are the same power, which means that derivative of one isn't going to help me find the derivative of the other. So you just have to find a way to rewrite this, where instead of being unable to play with that integral, you're able to play with the integral. Okay. Boom. All right. This is the straightforward type. Here, if I let u equal 2x to the fourth minus 1, the derivative is 8x cubed dx. So I look at my integrand, and I say I have to substitute for everything. So 2x minus 1 to the 8th is going to become u to the 8th. But then I have to substitute for the rest. I have x cubed dx. And this gave me 8x cubed dx. So if I divide by 8, I'll have x cubed dx, and that's the remaining part to substitute for. So this x cubed dx becomes 1/8 du. So put the 1/8 on the outside. So this is 1/8 u to the 9th over 9, which is u to the 9th over 72. And then substitute back. So remember what the u substitution does. It really just helps you figure out the chain rule backwards. Because when you take the derivative of this, you get the 9 over the 72, which is the 1/8, 2x to the 4th minus 1 to the 8th, which is that, times 8x cubed. So another 8 cancels, and you get the x cubed. So you can always check if you're doing these correctly by differentiating your answer and seeing if you get back to your integral. You will have lots of time in the final, or you should have lots of time in the final. We get 2.5 hours or something crazy for the final, or 2 hours and 15 minutes. I expect most of you will be done in about an hour and a quarter, maybe a little longer. So you can take longer. You shouldn't need more than an hour to an hour and a quarter for the exam. So you can use the rest of the time to check your answers. So you'll have time to integrate and then check by going back and differentiating. You should have time, okay? I'm not trying to make the exam last the whole period. Some of you, of course, will stay till the very last minute, but that's okay. So far, so good? All right, let's do integral number 3. So again, this is a relatively straightforward one. I look and I have a higher power of x in the bottom than on top. It's 1 power difference, so I know which one to make the derivative and which one to make u. So u is 12x squared plus 4x plus 3, and du is 24x plus 4 dx. Now I look in the integrand, and I see this will be u, that's not a problem. And this is 6x plus 1 dx, so to turn this into 6x plus 1, just divide by 4. Okay, substitute in. So the bottom becomes u, the top becomes 1/4 du. that's 1/4 log u, well, you don't really need the plus c, but whatever. 1/4 log of 12x squared plus 4x plus 3 plus a constant. 12x squared plus 4x plus 3 is always positive. You don't actually need the absolute values, but whatever. If you're not sure, leave them in. Even if you're writing an absolute value of 3. I mean, you're silly, but you don't really, it's not really wrong. Okay, so far so good? Okay, last one. So here, I see dx over x. That's 1 over x, right? Log x squared. So what do I do with that squared? Well, first of all, just use your rules of logs. Change that into 2 log x. Remember the rules of logs. So if you have something for power, you can bring the power in front. Maybe you forgot that rule. So now, so this is the same thing as saying, this is a 2 in the denominator, so I could pull that out. And I could say this is 1 over x times dx over log x, if I really wanted to break it up. So if u is the log of x, then du is 1 over x dx. Somebody see what I did? Where are we lost?
How did you get 1/2?
How did I get to 1/2?
Yeah,
Okay,
that's
so this is
what
1 over 2. So I can pull that out. 1 over x, because you can imagine there's a 1 times a 1 in here.
Right.
So 1 over 2 becomes here. 1 over x becomes this, and I'm left with dx over log x. Okay? You don't have to break it up like that, but that's so you can see what's going on. All right, so now we can substitute. So log x becomes u, and 1 over x dx is du. So this is 1/2 log of u, which is 1/2 log x. Log shows up in things like chemistry and physics. I can't think of where it's shown up in business. But use a log graph to smooth things. Are you watching the stock market? So the Dow Jones broke 24,000 the other day, yesterday. But if you took the stock market and you looked at it on a logarithmic scale, it's much more normally behaved. So the stock market right now, if you look back, way back, go back to say 1929, the stock market just looks like this, okay, with ups and downs in there. But if you put it on a smooth log scale, so if you look at what that means is, in other words, going from 23,000 to 24,000 is an increase of 1,000 out of 23,000. Going from 10,000 to 11,000 is an increase of 1,000 out of 10,000. Okay, so it's a much bigger increase. Going from 10,000 to 11,000 is 10%. Going from 23,000 to 24,000 is 4-point-something%. So if you adjust for that, then the stock market really kind of looks more like that. Okay? So in other words, if you think about inflation, if you think about the increase from 23 to 24 is not the same as an increase from 3 to 4, then it's still good. It's still going up, but it's not as dramatic an increase. It's still been quite a run since Donald Trump was elected a little more than a year ago. It's gone from 18,000-ish to 24,000-ish. That's a 33% increase in the stock market. This is a huge, huge increase. So you're really getting a bit of a blip right there, okay? If this tax bill doesn't pass, it's going to come down in a hurry. But the good news is, according to my Twitter feed, stock market is going to, I mean, the tax cut bill is going to go through, and you will all suffer for it, and I won't, because I'm old and you're young. There you go. But we won't get into the discussion of the merits of the tax bill. You guys are all business students. You should be paying a great deal of attention to what's going on in Congress on all of these things on a regular basis. Because you'll interview for jobs and they'll ask you, what do you think of the tax code What do you think of this? Next week we get the economic indicators for the rest of the year. You're going to be expected to know that stuff. But you don't have to know it today, and it's not on fun. Boom. So for example, we have a business, I don't really care what it's called, and marginal demand is d prime of x is negative 2,000 x over the square root of 25 minus x squared. Okay? Where d of x is the number of units sold at x dollars per unit. Okay? So in other words, this is d prime. This tells you how the demand is changing, where d is the number we sell at a price of whatever x is. Okay? So find the demand function. Not the marginal demand, the demand. Given that d of 3 equals 13,000. So what topic have we been doing for the last 3 days? You know exactly what you need to do. So this is the kind of thing that might show up in your job. As I keep emphasizing, you have to be able to do these things because you have to know if somebody else is giving you nonsense. It's not really, generally, I don't think most of you, this is going to be how you're going to spend your day. Well, I'll tell you, my first job at the Chicago Board of Trade, we had to figure out, try to come up with a function that would track the way the bond future, the forward future contract was behaving. We weren't very successful. It was too complicated at the time, given the math and the computer power that we had, but we gave it a shot. So I did get to use some high-level math early on, but generally, you have to be able to understand what's going on. So you need to understand the phrase marginal demand. Marginal it means derivative. It means how is the demand changing. So technically it means for the last unit you sell, but it really means how is the demand changing. It changes according to whatever this function is that they made up, that they put in the book. Okay? So if we want to find the original function where they gave us the derivative, when you want to go backwards, that's an integral. So you're going to want to integrate negative 2,000x over square root of 25 minus x squared dx. So you look at this, you go, I'm not scared. I know my calculus. Let's let u equal 25 minus x squared, not the square root of 25 minus x squared, just 25 minus x squared. Because remember, we can integrate the square root of u. Then du is minus 2x dx. So I look and I say, well, I kind of have minus 2x dx. I have minus 2,000. So if I multiply this by 1,000, I have minus 2,000 x dx. Now I've got everything I need to substitute. I look here and I say, okay, that's square root of u. And the minus 2,000 x dx is 1,000 du. So they're the same integral, but the second integral is much easier to do. So 1 over the square root of u is just saying that it's the same as saying u to the minus 1/2. Why would they give us d to 3? d did you give me d of 4? That's so stupid. Well, whatever. I didn't make up the problem. Okay, so the integral of this is u to the 3/2 over 3/2, bless you, which flip and make that 2/3 or 1,000 times 2/3 u to the 3/2, which is 1,000, which is 2,000 over 3. 25 minus x squared to the 3/2 plus a constant. And you say, okay, I'm done. So, well, not quite. Because we also told you that d of 3 is 13,000. So one last step. Yeah, I would have taken a number you can take the square root of, or whatever. So this is the function. But that's generalized. So now we can find it exactly because we know if I plug in 3, I'm going to get 13,000. So 13,000 equals 2,000. Oh, I see why they did 3. Never mind. Over 3, 25 minus 3 squared. I take back what I said. All right. 25 minus 9 is 16. Square root of 16 is 4. 4 cubed is 64. You get 13,000. It's 2,000 over 3 times 64 plus a constant. If I were to give you a problem that looked like this in the final, getting to about here is good enough. Okay. I'd give you easier numbers. So let's see. You get 39 equals 128 plus c. So negative 89 equals c. So the function becomes 2,000 over 3, 25 minus x squared to the 3/2 minus 89, and that's your demand. Isn't that fun? So how many of you got all the way to the end? Yes?
How did you find the value of e to the negative 1/2 when, isn't it supposed to be e to the 1/2? Yeah. 1 over 2?
Oh, it's supposed to be even 1/2. I apologize. Well, I should have said something sooner. Doesn't fundamentally change it that much. Let's see, 25, 9, square root of 16 is 4. You get 13/8 equals c, so you get 2,000, 25 minus x squared to 1/2 plus 13/8. Get there? All right. Well, you need to get all the way there to get full credit. Let's give you another one. Okay, this is how we give you a marginal profit. The marginal profit is is 9,000 minus 3,000x over squared minus 6x plus 10 squared, where p is the profit. Okay, find the profit function given that p of 3 equals 1,500. Same kind of problem. All right. So we want to integrate. We're going to want to integrate 9,000 minus 3,000 x over x squared minus 6x plus 10 squared dx. So look at this and you say, well, let's let u equal x squared minus 6x plus 10. And then du is 2x minus 6 dx. Can I copy that, right? No, I didn't. Oh, it's 2x minus 6. Oh, no. Okay, don't. I'm just reading this backwards. All right. So I could multiply this by 1,500. And I would get 3,000x minus 9,000 dx, which is essentially what you have up there with a minus sign. So this would then become minus 1,500 du over u squared, which is minus 1,500 integral of u to the minus 2 du. See, it's always going to do something like this. Yes?
Why can't you just make that original 1,500 du? Why can't you just make it negative 1,500 du?
Oh, I could.
Oh, you could?
I could. Yes, you could do a minus sign either way. You also could say, go up to here in the beginning and factor out 1,500. There are a couple different ways you could do it. So the integral of this is minus 1,500 u to the minus 1 over minus 1, which is the same as 1,500 over u, which is 1,500 over x squared minus 6x plus 10 plus a constant. You'd end up in the same spot. Okay, then it says P of 3 is 1,500. So 1,500 equals 1,500 over 3 squared minus 6 times 3 plus 10 plus a constant. Look at that. 9 plus 10 is 19 minus 18 is 1. So C comes out 0. So your profit equation is just 1,500 over x squared minus 6x plus 10. How we like that? All right, that's enough for today. Enjoy your weekend. I'll put the paper homework will go off late this afternoon. Have fun with it.